The System.Convert class is a veritable Swiss Army knife of data type conversions, with a conversion method for each of the many data types defined within the .NET framework. So as you can see, there's a 2sbyte method that converts to an 8-bit signed integer, a 2-byte 2int16, and so forth. This is a somewhat surprising duplication of functionality between C# and the .NET framework. Unlike some other language features, the C# compiler isn't generating code that uses the convert class under the covers. Instead, it implements its own conversions. But the nice thing is that you can select between the two techniques, whatever makes more sense for you and your code. Here's some code that uses the convert class in order to convert different data types. This is similar to the code that I showed earlier in an earlier module for using the cast operator, but I've just rewritten it to use the convert object. So I have byte, short, int, so forth, and here's the important part of the statement. So in this case, I want to convert to a 16-bit integer the results of this addition. I could convert each of these operands, but in this case I chose to perform the addition and then perform the conversion on the result of the addition. Here's an example of using convert to int32, a 32-bit integer, on just one of the operands. It converts that to an int and adds it to the integer value, and that's assigned to that integer value variable. All right, and then a bunch more examples of just using different data types. Now, one thing to note, as this comment says here, is that I don't have any decimal to string or string to char examples, because those are the exact same code as when I showed the cast operator, because you use the toString method, and you have to still use the toString method. There isn't anything magical in the convert object that changes what you need to do with those examples. Okay, then there's another way to convert data as well, and that's with the parse method. Now, this is available on all data types, so this is a method of the data types itself. So you can use this method to convert a string to a data type of your choice. In this parse method, what I'm doing is I'm taking some data, I'm converting it to a string, and then parsing that back into a particular value. So, a little bit of a contrived example, but it was an easy way to show what's going on. The idea here shows just how easy it is to use the parse method. So the important thing here is that I want to convert whatever's in this that I pass to the parse method, which is a string. I want to parse that to an int16. Okay, so a 16-bit integer. So I'm passing it a string, and in this case, in order to create that string, I'm taking the addition of short value and a byte value. The C# compiler does an implicit conversion in order to do that addition. I'm taking that result and converting it to a string. Now, in a real application, generally I'm going to have a string that I'm passing to the parse method. And often that string is coming from some sort of a form where the user is typing in some information. Their age, their birth year, their dollar income for annual income, whatever it might be. So that's input into the form as a string, and then I need to convert it to a particular data type, an int or decimal or whatever that data type may be. Okay, so that's all you need to do. The resulting value is an int16 in this case, and I'm assigning it to a short, which is the equivalent of an int16 for our purposes. Okay, and then there's a number of other examples that show how to do the same thing. And once again, there's no decimal to string or string to char because, again, you have to use the toString method instead. Okay, so let's talk about this because there's a potential problem here. So I have all these different conversions going to different data types and so forth. And for example, let's look at this one right here. So I'm using the parse method of a single in order to take a long value here and convert it to a single data type value. Now, in this particular case, in this specific example, I'm initializing long to 3 with a bunch of zeros. And parse understands how to make that a single value. But what if the string you pass to parse isn't anything it can convert to a single? In that case, parse raises an exception. And here's an example of that problem. So I'm declaring this string not a long value. It's not a long value, literally in the string. And then I have a float, 2000.12341. And what I want to do is, after I display it, I want to convert that. I want to parse it. I want to parse that not a long value into a single and then do that same addition. But this is a problem because not a long value is literally not a long value. It's a string. Parse doesn't know how to convert a string to a single. Now, it could perhaps convert it to 0, seeing that there's no numeric values, but that's just a little bit too much of a stretch. If you do something like this, the C# compiler assumes that this is a problem. And what's going to happen is that parse is going to throw an exception. So I'll go ahead and press F5 and run the code. And press C. So it displays the value, and a moment later we get the exception. And the exception is an unhandled exception of type format exception. Additional type input string was not in a correct format. All right, so in general, it's never fun to get exceptions, but this is actually a fine thing that the C# compiler does. Throws an exception, and you can use structured exception handling to handle the problem. Maybe you want to reprompt the user for a valid value, or maybe you can manually parse the value to figure out what's wrong. But this can lead to a lot of extra code that you have to write. So, with version 4 of the .NET Framework, Microsoft also introduced a try parse method on the same data types where parse is available. All right, so let me close out of this and end execution. And we have the try parse method. Now, the difference between parse and try parse is that parse throws an exception when there's a problem. Try parse is a completely different form of that method where you pass a variable that you want to have populated with the value, the parsed value, the converted value. And then the method also returns a result value indicating whether or not the parse completed successfully. Okay, so this is some code that I adapted from an MSDN sample that I found. And what it does is it uses the int.tryParse method in order to convert 32-bit integer values from strings. So what the code does is it starts by declaring this string array. These are all the different strings that I want to attempt to convert into 32-bit integer values. And then I have a for loop here. All this for each does is it loops through each of the values in that array. So I'm not going to talk any more about looping constructs, talk a lot more about it in a different part of the course. But just keep in mind that what this does is it's going to run this block of code for each of the values within this array. First it'll do 115, then it'll do for null, then for this value, then for that value, then for that value, and so forth. And as it does that, the value that it's currently working on is stored in the value variable. All right, then I declare a number variable. This is going to hold the result of the parsing. And then here's the tryParse method. I pass it the value that I want to parse, which is that value from the array. And then I use this as an output parameter for where I want to store the parsed value if it's successful, and that's that number variable. Okay, so I pass it 115. It's going to pass in 115 here, and if it can parse it successfully into an integer, it'll put that value, the converted value, into number right there. And then it also results in a true or false, indicating whether or not the parse succeeded. Because then I can use that result value in an if-else block here in order to do different things based on whether or not this conversion happened successfully. And so if the result is true, I'm going to output the value there. If it's false, then what I'm going to do is I'm going to generate an output. This is what's called a ternary operator. Again, not going to spend a lot of time here, but if the value is null, which it can be as one of the input values, and in fact that's the second value there, it's going to convert it to a string representation of null. Otherwise, it'll use the value, and then it displays a message using that output. All right, so it loops through that and does it for the next value, and the next value, and the next value, and the next value. But once again, it's important to understand that if I pass a value here that cannot be parsed to an integer, this isn't going to throw an exception. Instead, it's going to return a false, and then number will not have the updated value. Okay, so let me go ahead and run this code. And here I have the try to parse. I'll hit D to run that. And you can see that I converted 115 to 115, so that's the integer value. Attempted conversion of null failed, because I can't convert a null to an integer. This is a valid integer value, so it converted. This is not a valid integer value, because it would result in lost data. Not much, because it's 0.0, but the parse method is being conservative here. This is also not a convertible value, even though 16,667 is within the range of integers. It doesn't know what to do with that comma. So you have to strip out commas before you use this technique. In this case, this conversion failed because this is well beyond the roughly 2 gigabyte range of integers. So that failed. It was able to convert this because the parse method is smart enough to strip off leading and trailing spaces. So that converted to a -322. It understands the plus sign as well, and so it converted that to 128. And then this is a hexadecimal value, presumably anyway, passing as a string, so it could be anything, but it can't directly convert hexadecimal values. And the nice thing is that we didn't get any kind of exceptions. Some of the parsings failed, but we just handled them in code. So we had to write a little bit of code, but we got a lot of benefits.